Unit 5, Lesson 5, Trig Identities Part 2. So in this lesson, we're going to continue proving identities, except now they're going to be a little bit more complex than in the last lesson. So we're going to look at examples that might require you to factor in order to solve them, which we started at the end of that lesson before. You might also need to find common denominators between fractions so that you can add them. And you might have to creatively multiply by 1. Okay, and I'll show you what I mean by that in these examples. So let's prove this first one here. Is the left side equal to the right side? So I'm going to start by solving the left side because it looks a little bit more complex, and I'm going to try and get it to look like that right-hand side. Okay, so it might be good to have that bank of identities right beside you for this lesson. All right, and I know in the last lesson I always wrote out the full right side and left side every time, but you can actually just work on the left-hand side and the right-hand side separately. That's just a little bit less writing. Okay, so let's try and make that left side look like the right side. So first thing I'm going to do is I'm going to use my Pythagorean identity rearranged, and I'm going to swap out that cos squared theta with 1 minus sine squared theta. So one thing I'm going to notice, and this is an example of when you can use factoring to solve a question, is in that numerator I have a difference of squares. Okay, and if some of you find that hard to see, again, let's do what we did in the last lesson. Let's replace sine theta with x. So instead of writing 1 minus sine squared theta, it's the same as writing 1 minus x squared. And I think all of you can look at 1 minus x squared and know that that's a difference of squares, right? And you'd factor that like this. Okay, so then to factor 1 minus sine squared theta as a difference of squares, just replace sine theta back in for x. Okay, so if we factor 1 minus sine squared theta using difference of squares, that turns into 1 minus sine theta times 1 plus sine theta. And now this is great because these two guys cancel out, and we are left with just 1 minus sine theta. And my left side is now equal to my right side. So we have used the identities from our bank and some factoring to prove that the expression in the question was true. Okay, part B, let's solve this identity. So I'm going to start with the left side because the left side has a reciprocal identity in it, and I know from that list of tricks that writing your reciprocal identities in terms of sine and cos is a good thing to start with because it's easier to prove an identity that is all written in terms of sine and cos. Okay, so I'm going to replace cosecant with 1 over sine theta. Okay, now I like to try and add those two together, 1 plus 1 over sine theta, because if I look on my right-hand side, everything's added together. It's not that we have two different terms. So in order to add 1 plus 1 over sine theta, I need common denominators. Okay, so I'm going to multiply 1 times sine theta over sine theta. So this is showing you that one trick that I mentioned earlier, okay, creatively multiplying by 1. So I'm going to multiply this by sine theta over sine theta to get a common denominator. Now I'm left with sine theta over sine theta plus 1 over sine theta. Okay, they now have common denominators. So when we add those two together, we have sine theta plus 1 all over sine theta. And now our left side is equal to our right side. Okay, so this was an example where we used the reciprocal identities as well as the trick that involves getting a common denominator by creatively multiplying by 1 That's what we did here, in order to prove an identity. Okay, part C. I'm going to start by simplifying the right-hand side because it's a bit more complex, but I'm also going to change the left-hand side into 1 over tan theta using our reciprocal identities, because I know one of my tricks is you should probably change out those reciprocal identities. So let's quickly simplify that left-hand side. I'm even going to write it in terms of sine and cos, right? Because tan theta is just sine theta over cos theta. And then 1 divided by sine theta over cos theta is just, we can multiply by the reciprocal, so we get cos theta over sine theta. So we get cos theta over sine theta. Okay, now that we've simplified that left side, let's get over to that more complex side. So the right side, I'm going to switch out, I'm going to use the reciprocal identities to switch out that cotangent theta, and I'm going to switch tan theta into sine theta over cos theta. Okay, then in that numerator, I know that 1 over tan theta is the same as cos theta over sine theta, using that reciprocal identity extended. Okay, now I need to add both the terms in my numerator and add both the terms in my denominator. So in order to add 1 plus cos theta over sine theta, I need common denominators. So I'm going to multiply that 1 in the numerator by sine over sine. So I'm going to creatively multiply by 1 so that in the numerator they get common denominators. Right, because 1, right, because sine theta over sine theta is just 1. Okay, so I didn't change the question. Same in the denominator. 1 is the same as cos theta over cos theta. So I might as well write it like that so that I have common denominators. Okay, let's continue simplifying our right-hand side. So in the numerator, sine theta over sine theta plus cos theta over sine theta is sine theta plus cos theta all over sine theta, divided by, in the denominator, cos theta over cos theta plus sine theta over cos theta is cos theta plus sine theta, all divided by cos theta. Okay, now to divide two fractions, it's the same as multiplying by the reciprocal. And then we can cancel these guys out, and we're left with cos theta over sine theta. Okay, so the left side is now equal to the right side. So we used our identities from our bank and the idea of gaining a common denominator by creatively multiplying by 1 in order to prove that this was in fact true.